All right, this is the Geometry Unit 3 Lesson 2 video. This is going to be a little bit of an expansion on what we covered in Lesson 1. So I'm going to jump back over here and start a new drawing. And a lot of this is going to be related to something we talked about in Lesson 1. We talked about these 5 different relationships between what we called transversal. If you remember, we had transversal line. And in that, we went over 5 different relationships. Not these first 5, but the ones down here under transversal lines. We talked about alternate interior, alternate exterior, same side interior, same side exterior, and corresponding. So really hope you have those down. It's really important that you're able to see where those are and identify them pretty quickly, because in this next lesson, we are looking at do a new drawing. There we go. We are looking at how those, what those tell us when we are dealing with parallel lines and a transversal. So again, we're saying when we have 2 lines that are parallel, call this M and N, and we say M is parallel to N, that's what this symbol means. And then we have this T line coming through. The relationships we talked about previously have some kind of unique characteristics. So if we have this situation, then we know some things. So I'm going to break these into two categories. The first category is going to be congruent pairs. In other words, these are angle pairs from the previous section that when the lines we're looking at are parallel, like we had here, they are congruent. So the ones that are congruent are the following. I'll draw 3 diagrams. So when we have these, 3 of them are going to be congruent pairs. The first congruent pair are corresponding. Corresponding angles, when these 2 lines are parallel, the corresponding angle pairs are congruent to each other. Also, when the lines are when the lines are parallel, the alternate interior and alternate exterior angles are congruent. So alternate interior would be like this angle and this angle, for instance. Look on the previous lesson's notes for other examples of alternate interior angles. So there is more than one. And then lastly, alternate exterior angles are congruent. This is an example of a pair of alternate interior angles. So those are the 3 angle pair relationships in these transversals. Remember, this is all referring to these situations that you see here when you have a transversal line. When the lines are parallel, and I'm talking about these lines here, M and N, as an example, then these angle pairs are congruent. What does congruent mean? Congruent means equal. Okay, so the measurements are equal. Okay, I'm going to write that down. The measures are equal. Okay, so that's one set of relationships. So those 3 all fall under the congruent pairs. There is another set of relationships that are supplementary relationships. Okay, remember, supplementary means you have 2 things that add up to 180 degrees. That's what supplementary means. So what are these supplementary relationships? Let me draw 2 diagrams. And it's really just the 2 we haven't done yet. Again, we have M and N. We have line T cutting through. And so the two that are supplementary are going to be same side interior and same side exterior. So both of these would be examples of relationships where the angles are supplementary. So for instance, this angle right here and this angle right here are same side interior angles, so they add up to 180. Also over here, same side exterior. That means this angle here and this angle here add up to 180 degrees. So that's the main concept that we're dealing with here. So these 5 ideas, these 3 are congruent pairs, these 2 are supplementary pairs, are the main idea of this lesson 2. So I've kind of summarized what you have in this lesson, and then you're basically going to be doing proofs. There are going to be some that are very short proofs, and longer ones we'll do together. So I'm going to walk you through kind of what you need to be doing in the lesson. So for instance, number 1, choose the correct answer. You have a transversal line diagram. You have a statement here telling you that these lines are parallel. And then it says angle 1 and angle 5 are blank angles. All they're asking you here, which relationship is that? Corresponding, alternate interior, alternate exterior, same side interior, or same side exterior. So you just need to choose 1 and 5. What are they? Which one of those 5 options is 1 and 5? That's it for number 1. That's also similarly what you have to do in number 2. Which theorem or postulate shows you that angle 3 is congruent to angle 6? So there are 6 options, and I'm going to talk about vertical angles here in a little bit. So we'll come back to that one. But so that's definitely not the answer here, but we need to look at angle 3 and angle 6 and ask the question, again, which category does that pattern fit? Corresponding, alternate interior, alternate exterior, same side interior, same side exterior. So you decide what is 3 and 6, and you choose the theorem that corresponds with that. And that's all you got to do on that one. All right, so I'm going to pause and go back to our notes and tell you about one other special case for these relationships. It's one we've already discussed, but we need to discuss again just to drive the point home. We discussed previously what this is called when we have angles that are at an intersection that are across from each other. We have like this angle as an example, and this angle pair. This is called vertical angles. So vertical angles are angles that are across from each other at an intersection point. So these purple angles would be congruent to each other, and these yellow angles would also be congruent to each other. Okay, each one of those would be an example of vertical angles, and vertical angles are congruent. So that's actually, just tell you up front, that is what number 3 is dealing with. So starting at number 3, going down through number 4, and number 5, number 6, so numbers 3 through 6, you have to do 2 things. You need to decide angle 2 and angle 3. You need to know 2 things. Are they congruent or supplementary? And then also, what is the relationship? So you'll notice there's 5 options here. 3 of them are relationships. 2 of them are either the supplementary or congruent answer. So I would actually do this I would actually do this blank first and then do this blank. So what I mean by that, and I'll just do this as an example, I need to decide 2 and 3. What is their relationship? They are vertical. I'll just tell you right now, they are vertical. So we can see that because they are at an intersection point and they're together across the vertex, across the intersection point from one another. So I'm going to automatically choose vertical angles. Then I decide, is a vertical angle a congruent relationship or a supplementary relationship? So we have these 3 that are congruent. We have these two that are supplementary, and then we also have vertical that is congruent. So really only the same side, interior and exterior, are supplementary. All the other ones, corresponding, alternate interior, alternate exterior, and vertical, are all congruent relationships. So then I know that this is going to be congruent. So they are vertical and they are congruent. So then the next one, you need to do this one, 4 and 6. What is the relationship between 4 and 6? Which category do 4 and 6 fall under? And then after you do that, what is the relationship, right? Are they same side interior, same side exterior? Therefore, they are congruent. Are they supplementary? What is it? So you have two answers. You need to name the relationship, and then you need to say what the relationship means. So your first answer is one of the categories here. The second is the big category, either congruent or supplementary. And that's what you do for 3, 4, 5, 6, and 7. Or no, 3, 4, let me check. 3, 4, 5, 6. Starting in 7, we have a proof. So I told you in the past I do the proofs with you, so we're going to walk through this together. So let's kind of get into that mindset, but we know we're going to be looking at the alternate exterior angles theorem. So it says we have given L is parallel to M, and it's cut by transversal T. L is parallel to M and it is cut by transversal T. That is our given. Automatically, we know the first statement in any proof is given. That's going to be answer choice F. Always take care of that first. Okay, so we look at number 2. So something is going to be said about corresponding angles. Okay, corresponding angles. So we need to decide of our answer choices, A, B, E, and G. So see how these are all angle pairs? One of those has to be a corresponding angle. So let's see which one is corresponding. We have 2 and 7. Those are not corresponding. Those are alternate exterior because they're both exterior and they're on different sides. So it's not A. Then we go to B, 2 and 6. 2 and 6. Those are corresponding. They are in the same position. They're on the top right side of the intersection. Top right side. 2 and 6, those are corresponding. That has to be our answer. Answer choice B. Then they do 6 and 7. So we look at 6 and 7. 6 and 7, what is the relationship? We have a few options. We have alternate interior, we have vertical angles, and we have same side interior. Well, 6 and 7 are definitely vertical angles. I can just run down here and look at that right over here. Vertical angles. They're across from each other. So we run back and we say, okay, D has to be the answer choice here. That is vertical angle relationship. And then lastly, my last line of my proof is always the thing I was trying to prove. So I actually don't need to even think about that one. I know that the last statement must say angle 2 is congruent to angle 7. And so we choose answer choice A. So notice all I'm doing is just looking for either the angles that fit the statement or the statement that fits the angles. So let's look at the next one. Similar concept. We want to prove the same side exterior angles theorem. We're given L and M and cut by transversal T. Again, the first reason to any proof is always given. So we hop down here, we find given is answer choice H. Now let's follow this through. Then it says angle 1 and angle 5. And it says corresponding. That makes sense. Those are corresponding angles. The measure of angle 1 is equal to the measure of angle 5. That's just going to be the definition of congruent angles. B. Anytime you go from congruent to equals, you're dealing with the definition of something. In this case, the definition of congruent angles says that if two angles are congruent, then their measures are equal. That is answer choice B. Nope, not D, B. Angle 5 and angle 7 are a linear pair of angles. That is a definition of linear pair. And then because they are a linear pair, we know that they add up to 180 because that's what linear pairs are. So then 5 and 7 add up to 180 is our next answer choice. Next, what are we doing? I don't know, definition of supplementary angles. Well, that means I need to find a statement that says something about supplementary angles. Well, we already been dealing with angle 5 and angle 7, so it's got to be that. So we're saying angle 5 and angle 7 are supplementary. That is A. Next, 1 plus 7 equals 180. We're doing that because we're taking the statement from number 5 and we're replacing angle 1 for angle 5. So angle 1 comes in and now we have this new statement. We're substituting. We've substituted angle 1 in this equation for angle 5. And then we're done with the proof. So hopefully that makes some sense to you. I told you we'd work through the proofs together because I'm not expecting you to have those down completely. But everything else you should be able to handle. And that's the end of our lesson 2 video.